Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to build a time-based and data-driven day and night solution for your Unreal Engine games. So let's get started. This tutorial will be an extension of my time simulation series, where we'll be using the core chronometer component that we created in that series to be able to drive our day and night cycles within our sky sphere, as you can see right here. And then, so I'm going to go ahead and leave links to that series below in the description below if you're interested in checking that series out. But we will be using that component to help drive this system. So I'm just going to go ahead and stop this real quick and scoot this up a little bit and take this off. So I'll be using a third-person solution. So under Games, third-person, C++. I'm going to be using scalable, starter content, and then when I created hit the create button, and that will should give you a solution a little bit like this. And then all I did was, when I created that solution, I went and imported over the core components for the chronometer and the chronometer data structures. And then I went ahead and recreated the game instance information, since we'll be using this core chronometer as a simulated clock to help drive our day and night cycles. All right. So in order for this to work with our day-night system, we just need to make 3 little enhancements to the code itself. And I'm just going to go pull up my other solution real quick, so I've got it all ready for you. And so first off, under the core time configuration structure, we just need to add 2 small functions. And so the first function is our get seconds in day, and then the second function is the get time scaling. So if I go ahead and fix these green squigglies, and it's going to just go ahead and set up some code here, we'll be able to add the implementation. So the first one, which is the getting seconds in day, all that's going to be doing is it's going to be going into our structure here, and it's going to be pulling hours in day. And with that, we're just going to then convert that to, using our conversion struct that we defined in here. So this has the constants for time, as well as conversion calculations down here. And these are static structures, static functions, so that we can just call them as if they were just functions without having to instantiate an instance of this structure. All right, so the first one again is converting those hours into day, and our simulation will be using both hours in day as well as days in year. And we'll be using this when because our solution here will be supporting both hours in day, but also will have time periods. So we can create various time periods, and it can then manage based on the time period and based on the position. We can get the right information and create whatever skies we want it to look like within those time periods. And we'll discuss that a little bit more when we get to time periods. But all right, so getting back to, so we have get seconds in day. So this again will take the hours in a day and then turn that into raw seconds. And then the next one we have is the time scaling. Get time scaling. And what this is going to do is this is going to create a ratio. So when we create, since we're going to be using vector curves to map the pitch and the yaw of our sun in the sky, right? I want to be able to scale that up and down. So again, first we're going to take the number of hours in a day, and then I'm going to then divide. So it's going to be seconds an hour divided by the hours in a day, the seconds, right, of an hour in a day. And then what that will give us is a ratio that I can then use to then plot on a standard curve. And we'll show that again when we get to the curves. But this is a function that we're going to be using just to kind of create that plot for us. And this will allow us, so whatever we define as hours in day, this will get us the proper scaling. So that way we can have, if you wanted to have planets with different hours and different days, you could do that and, create and get that information plot perfectly every time using just a standard curve. All right, so now that we've got those two out the way, The only other change that I needed to make, or addition I should say, that I need to make, was to our core chronometer. And as you can see under here, we have get simulated days, hours, and minutes. The only thing that I'm missing that I need in order to do to drive the sky simulation off this is just to add the get simulated seconds. So what I'm going to do, let's go fix the squiggly, and this works the same way as kind of like the minutes and the hours and the days. It's following the same format. So the only difference here, I'm just going to go copy this, and we'll just paste this down here. Yeah, the only difference here is that we're just going to be getting the current seconds. So we created a function when we created this setup originally for get current seconds, so we're just going to go ahead and just pull that. So that's already there, and then it just follows the same pattern, and we just want to make sure that we get the offset of those seconds as well. So we're just passing that through the offset, and then we're passing back the offset. And that is all we need for the chronometer. So I'm just going to go ahead and close that. And then once again, so under the game instance, we're going to be using a custom game instance, and then I just ported everything over from the time simulation over to here, since time simulation is going to be driving the Skysphere. So, all right, and so nothing's changed, everything stays the same here. So I'm just going to go ahead and close that. I'm going to come back to the editor, and I'm just going to go ahead and compile, since we've added some functions. So we'll just make sure we get a good compile before we move on. All right, so now that we've updated the chronometer to be able to support our Skysphere, let's go ahead and create the Skysphere actor as well as the Skysphere data structures that are going to be used to configure the Skysphere. So what I'm going to do is under content, you can come to C++ classes. There's the folder that we created, which has the project information in. And then under there, all I did was when I ported everything over, I just created a subfolder for chronometer to keep the time system separate from the Skysphere. So let's go ahead and just create the Skysphere real quick. So to do that, I'm just going to go ahead and go new class. Skysphere is going to be built on top of the actor class. So it's going to derive from the actor. And so I'm going to hit next. Go ahead and give this a name. So I'm just going to copy that and paste this over here. So I'm calling this Core Skysphere Actor. And under public, I'm going to put this in its own folder. SPH Skysphere. So it'll be under the Skysphere folder. Again, keep things a little bit more organized, since we have two systems here in this solution. All right, so let's go ahead and just create that. Let Unreal Engine and Visual Studio do their thing. It's compiling. Hopefully we'll get a good compile. All right, we've got a good compile. I'm just going to come into here and I'm going to say reload all. All right, so right now we just have a default actor. We're not going to do anything with this right now. We'll come back to this once we've defined our data structures, since we need the data structures first. But we have our core, and this is pretty much what Unreal Engine will create for us when creating a actor on top of the a actor class. So it's automatically giving us begin, play, and tick, so that we can start filling that out. All right, so I'm just going to go and close these real quick. And let's go ahead and build that structure, our first structures. So again, I'm going to come into all, C++, public, Skysphere, and I'm going to right click and come new. So out of the box, Unreal Engine doesn't have a way to create structures. So what we're going to do is we're just going to use this empty C++ class, and then we'll convert this into what we need. So I'm just going to go ahead and hit next. And then I'm just going to go ahead and bring over the name. And so this is going to be based for table. I'm going to be using these structures in the context of a table. So what I usually like to do is use the row suffix on the end of the name. That way, yeah, when I'm looking through code and I see the row, I know, okay, that is going to be used as a data, specifically for data tables within Unreal Engine. All right, it's going to go into public, SkySphere, so everything looks good there. So let's go ahead and create the class. All right, and we've got a good compile, so let's bring this in. I've got to say reload all. So it's now added. I'm just going to go minimize that and just maximize this. So here we are, we've got our two files. And let's go ahead and convert this from a class into an Unreal Engine structure. And I'm just going to go ahead and so let's first go ahead and just put the include files in first. We're going to be building a lot of structures, so what I'm going to do is I'm just going to go and set up the default first, and that way I can then just copy it over and clone it. And I'm just going to go and keep all of the structs in the same file, since they're all related and they're all kind of needed to drive each other. So first off, we need to make sure we've got this generated, and this needs to be at the bottom of the include stack. Then we need to add the use struct, and I'm going to put in the blueprint type so that it can be blueprintable. Then I'm going to change this from class to struct. And then Unreal Engine likes to put an F prefix for structs. And I'm just going to go ahead and put the F there and the F there, just to satisfy everything. I'm going to go ahead and just remove this, since we're not going to need anything in here yet. And then, since these are just going to be default constructors, I'm just going to go ahead and just put these curly braces there, and so that should satisfy that. And then lastly, since we're using the generated.h, I'm going to go ahead and add this up here. So that looks now like a standard setup. All right, so I got a little purple down there. Okay, Visual Studio is just taking its sweet time to recognize that. All right, so that should give us the basic structure of what we're looking for. I'm not going to go ahead and turn this into a row yet. That way I can just copy and paste it and just reuse it. The basic structure, since we're going to be writing a lot of structures. There it is. So let's go ahead and just do a quick compile, make sure everything's still okay. And everything looks to be okay. So far, so good. All right, so I'm just going to give us some space. All right, so we've got a lot of structures here. So because I'm going to be putting all the structures in the same file, I need to create an order of operation. And so I need to put the inside structures, and since this is going to be a complex data structure, I need to put the primitive structures in first, and then build on top of it. And everything's going to then build back down to the row structure, which is down here. And the reason why I'm going to do this is that way when the compiler compiles, it needs to see those primitives first defined before it can then compile the structures further down the file. So first off, I'm just going to go ahead and just copy everything there. So the first structure or primitive structure I'm going to be creating is this is the transition angle. So everything that we're going to be doing is going to be based off a transition angle. And that transition angle is pretty much going to be based on the pitch and the yaw. So as we're kind of going across the sky, we want to track the pitch and the yaw, and we want to then check the pitch and yaw to determine what we want to do. And I'm using both pitch and yaw because that way we can use, that way if you wanted to have an evening, a midday, and a dusk, right, before you go into night, you can change your materials based on the pitch and the yaw, but you can also change the light intensity based on the pitch and yaw, and we'll be doing that when we get to setting up the table and then going into the simulation. So that's our transition angles taken care of. So next, after transition angles, I'm going to be going straight into the sky material configuration. So, and this is going to allow us to switch out materials on the sky sphere itself. So I'm just going to copy these. So the two properties here, we've got the element index, and then we actually have the material, and we'll be using the uMaterial interface. And we're just going to default this to null. So what this will allow us to do is in the data table, we can actually select the materials that we want, and then we can say what index in the material list do we want to change it at. So if you're just using one, it'll always be at element 0. But if you had a composite set of materials where you had a layered approach and you only wanted to change out certain materials, you could do that too. So that's what that's going to allow us to do. So again, it allows us to do things in a little bit more targeted manner if we need to. And again, just making sure all the standard configuration and the constructor destructor are all good. I'm just going to go and minimize that. So that's our transition angle, and then that's the core sky materials config done. All right, so next is going to be in this nested structure, we're going to want the core sky configuration. And this is pretty much going to tell us, bring over the properties, and let's just fix the constructor and the destructor. All right, I'm just going to minimize that real quick. All right, so what I'm doing here, so I'm actually using an f text, but you could use an f name as well. And this is just a label. This is just for internal purposes, so that I know what I'm looking at when you have lots and lots of these structures in a table. It's just good to put a label there so you know what you're looking at. But here, what we have is the sky angle range, and again, this is coming off the transition angle right here, pitch. And then we actually have the material. So we can define the range that we want that material to be switched into. And again, we're using the T array, so we can have an array of these if we wanted to switch multiple material. If we had a composite material system in our sky sphere versus a single material. All right, so I've got all of that done. So next, after that, again, I'm just going to go ahead and just copy the struct. So now that we're done with the materials, now we're going to move on to the actual light sources. So this is the core light configuration. And I'm just going to go copy the properties, bring those over, and then let's just fix the constructor and destructor. All right, so under here, we have a name. So again, this is purely for internal purposes, so I know what light source I'm looking at. And then under here, I've got the angle. So this is going to be the angle of the light source. So this is the light source at what angle. And then I have the lux. This is how much light intensity we want to put. So this will allow us to... Oh, and I forgot the interpolation. Let me just bring this over real quick. And the interpolation. So this will allow us to actually set light intensity. So if you wanted to have maximum light intensity on your sun during like the midday period, but you want mornings and evenings to have less intensity, we can then change that intensity based again on the pitch and the yaw of that primary light source, or aka the sun in the sky. And so we can do that right here. And then the interpolation speed is how quickly do we want it to switch between the current and the target. So this is the target, and then the current is what it actually is at that moment. And this is again how quickly we want it to change on each frame. All right, so next is going to be the orbit information. So actually, let me just copy this one since it's smaller. All right, so this should be the orbit information. And again, all right, so this is the orbit information again. So here, this is where we're going to be using the vector curves. So we're going to be using a vector curve to plot the, to be able to convert the time into position. And we're looking for two positions. We're looking for both the pitch and the yaw. And then also, this is where we can set up the luminescence, which is again the how intense we want that light based on that position, based on this curve. Okay, so that's the light orbit configuration. All right, and then I think we've got a couple more. Oh, nope. It's got one more before we go ahead and define our row, and that is going to be the time period. So I'm setting it up so that I can support multiple time periods. If you want to use just one time period for one orbit, you can. But if you wanted a game like where you wanted to have different seasons, right, and different seasons could have different orbits in the sky for the sun, you could do that through using the time period. And all the time period is just again a label for just to make it easy to know what I'm looking at. And then we have a T-map of orbits. So this is all the primary light sources, all of the light sources that we want our sky sphere to control. And then this is the sky configuration, which is the materials that we want to change within the sky based on the orbital position of the primary light source. And while we have a primary light source, we're also able to control other light sources too. And that could be any celestial body or even the starlight itself. So we'll have the ability to do all of that. All right, so now that we've got all of these structures defined, so transition angle, sky management, sky configuration, light source object, time period, let's go ahead and turn this into a table row. So to do that, first off, we want to inherit from table row base, and that is why we've got this up here. And then all I'm going to do is we're going to have two properties, and these two properties, again, I've got an f text label. You can use an f name if you want. I'm just using text. And then also we just have an array of time periods. And so if we go back to the sky sphere row, time period row. So as I said, right, we were going to be using both this and this. This is going to help drive the time periods, and that's why we want to use this. So if I have 365 days in a year and I only have one time period, then one time period is going to cover it. But if I have two time periods, so I want to have a winter and a summer, then our system would take this number, halve it, and then determine which time period we want to bring up, whether it be time period for summer or the winter, depending on how you want to start your game. Okay, so and that's what that will do. So I'll just go ahead and close that. And then lastly, I'm just going to add a little helper function. So since the time periods are here, this will help us get the time period that we want. So I'm just going to go ahead and just keep this logic all together. So again, days in year, so it's going to take two parameters, days in year and the current days, right? So this is the number of days in year that's going to be coming from the chronometer and the clock that we're using, and then this is the current day that it's that we've said it's on based on the chronometer system. And then what this is then going to do is it's going to take the days in year. Let me just get this color coded. Check to make sure that we actually have a time period, otherwise this could be a problem. And so if we have more than one time period, then we'll go ahead and start calculating this. If we don't have more than one, then we'll just bring back a default. And then what we'll do is we'll try and figure out which time period we're in. So again, we're going to say this is the days, so number of days in year based on time periods, which will get days and time period. Then we want current days, days and time period. That gets us the index, and then from the index we'll do another check. And so then what we have is we have two functions here. So if we are between so if we're talking about 10 days, right, in a year, and if we're between days 1 and 9, then we'll go ahead and make the check based on the index. But if we're on day 10, then we just need to take whatever day 9 is and then come back there. So that's what that's going to do. That way we'll get, that should cover all of the days for us. All right, so now that we've got that set up and we've got our structures set up, let's make sure that we've got a good compile and make sure everything looks good. I'm just going to go ahead and close this out. I'm going to move over to the editor. And let's go ahead and hit the compile button. All right, now we're going to go compile. All right, so now that we've got the data structures, let's go ahead. I'm just going to go ahead and let's go ahead and create that table and fill it out. So I'm just going to come up to here. I'm going to go to the C++ classes. Actually, nope, we're going to go to content. And I'm going to come on to blueprints. So again, since I brought the clock system over, we already have the time set up. So I'll just bring this over real quick. So as you can see, we've got default time and local time, and this is the clock configuration that we're currently using. So I've got universal time. Right now, my simulation in the demo is actually running off local 1, and I've set it for 2-hour days. Versus 24-hour days. So again, highly configurable, and the Sky system will feed off the information set in the time simulation system over here, as well as the offset and everything else. So that will work together. So under configuration, we're going to create another table. So I'm just going to expand this out a little bit more. And I'm just going to go ahead and under date. Yeah, why not? I'm just going to put it here. So under data, we're just going to come to miscellaneous. And if we've done everything right, we should be able to come up to data table, which is here. And under none, and under here, we should be able to see there's core chronometer configuration. That's how we built this table. And then we have core sky sphere row. And this is how we're going to build the row table for that. And I'm just going to call this sky underscore config. Hit save, and let's go ahead and open this up. So here's our raw table, no records in here, so I'm just going to go ahead and hit add. So that's going to add our first record. And let's give this a bit more of a descriptive row name. So I'm just going to copy that and put that in there. So this is sky, default sky, but it could be whatever you want to call it. This is all configurable. And so let's go in and start filling this out. So under here, we've got time periods. We have no time period set. Actually, we've also got a label. So let's call this... call this the Earth. And under here, I'm just going to go ahead and set up a time period. So we're just going to click on time period, and I'm going to open that up. And this is just going to be our summer time period. So I'm just going to label that summer so I know what I'm looking at. But again, you could have a second one for winter. Or if you want to do 4 seasons, you could have summer, winter, autumn, and spring. You can have as many time periods as you want, but you have to have at least one time period. All right, so now that we've got that done, I'm going to go ahead and set up the sky configuration first, and then we'll come back to the light orbits since it's a little bit easier. Now I'm going to add 3 configurations here. And this will become a little bit more apparent when we get into the curves and how the curves are set up. But what I've done is I've actually split the night into two parts. I've got night AM and night PM, and then we've also got the daytime, which is all one split. So night AM, and I'm going to put night PM here. I'm going to put the labels in first. Okay, and go hit save. All right, and then under, so night PM, and so the way that the curve works, right, I'm going to be tracking pitch, I'm tracking pitch and yaw, so yaw goes from 0 to 360. 0 being at midnight, 360 being at midnight, and so because of that, I need to split my night into morning night and evening night, and so we need to then set the material, which is here, and I'm only going to use one material for night. Let's go ahead and just set the materials first before we go ahead and set the angles. So for night, I'm just going to be using the procedural Sky Night, and that comes out the box. There it is. So I'm just going to go ahead and just use this material since it comes out of the box for the night. And so I'm going to use that one for there. And again, I'm just going to add a single element that we can switch. But as you can see, we can add as many as you need. If you have different materials you want to switch out, you can do that. And then procedural night sky. And again, I'm only using it in the 0 position, so we'll keep that there. And then our daytime, just going to go ahead and close that and close that. Going to add that. And here, this is just going to use the simple sky dome material. And there it is. All right, so those are the materials set up. So now we just need to set up the transition angles where we want those materials to show up. So to do that, I'm just going to come back up to the nighttime AM. So for nighttime AM, right, that's going to be, I'm going to set a min pitch angle of 0 and a max pitch angle of 67, right? And I'm using 60, and this is positive because if you think about that, we're going to be controlling directional lighting, and so when the sun is at high in the afternoon, right, it's actually pointing down, and so the direction is actually going to, and so it uses the negative versus the positive. It's a little confusing when you think, to think about it that way. So if it's positive, on the other hand, that means that the sun is now facing up at 90 degrees, and it's actually going to be hitting the back of the map. So our pitch angles for nighttime is always going to be positive, and daytime is always going to be negative. It's just how that is. And then here, instead of 360, I'm going to set this to 90. So we're going to be using, my standard curve is going to be using a 12-hour cycle period. So since the primary light source is going to be on a 12 hours a day, 12 hours a night, so we want to switch at the 90-degree mark as when it comes to the yaw angle. So between 0 and 90, it's going to be nighttime. And then when we get to daytime, it's going to be, let me just pull that one up. It's now going to be, and again, minimum pitch angle is going to be negative 69 and 0. So that's the horizon is 0. And I'm only going to take it up to 60. I think I'm bringing it up to like 66.5, but I'm just going to set it to 67 here. So it should never reach 67, but that's the, and the reason why I'm doing that is because that's kind of like the maximum height that the sun will actually get in the sky if you're on the equator during the summer and the winter time. And you can find that information out. I just Googled that information. So again, that's the maximum. This is the minimum. So our sun's never going to be fully overhead at 90. It'll be off at a slight angle, which I think is looks a little bit more natural when dealing with sunlight. And again, the yaw angle, daytime is considered between 90 and 270 since I'm using 12 hours of day, 12 hours of night. But again, this can all be configured, again, based on your time period, based on your sun track. And all of the materials here are based on the primary light source, which is our sun track. All right, so, and then again, let's come to nighttime in the PM. And I'm just going to bring that angle up. And again, minimum angle is 0. Max angle again is 67. Just going to keep it simple. And then the yaw angle is going to be starting at 270, which is the west. And then we're going to end at 360, which again will be midnight. All right. So let's make sure everything is there and all the data is there. All right, so that is our sky data. So let's go ahead and add our light orbits data. So I'm just going to go click on this. And let me go over to the other solution where I've already got those numbers crunched. All right, so the first one, so this is a T map, so I can create a key, and it's running off a key value pair. So the first one is going to be sun. So that's my sun. That's going to be that's what I'm going to link to the primary orbit when we create the SkySphere system. And so that's the primary light source that's going to be driving everything else. And I'm just going to call this summer. So this is using a summer orbit. I'm not going to work on the curves yet. We're just going to go ahead and just put the data in. Once we've finished the SkySphere active, then we'll come back and we'll come back, create the curves, put those curves in, and then everything else should start to run off the configuration. But that's where we'd put the orbit. And then I'm just going to set up the illuminescence for the sun. So under here, I'm just going to use 3 luminescence. And those luminescence are going to be broken up into kind of midday, mid-ish day. And at midday, I want the luminescence to be 6, or at mid-ish day, it's going to be 6. And the interpolation speed, I'm just going to keep this at 0.5 for now. But again, it's adjustable. Then we're going to have a morning, and we're going to have an evening. And I'm going to change that to, make that 3.0 for morning. So I'm just going to halve the illuminescence for morning and evening. So that should kind of bring the intensity down a little bit as the sun's kind of moving off into between the easterly and the westerly positions versus directly overhead. And then again, everything's based on angles. So this angle is actually going to be mapped to the actual angle based off this curve. So that way we can have different celestial bodies. So if you wanted to in the nighttime, you wanted to have the moon and maybe another moon, right, traveling around in orbits, you could then set the intensities there too for those lights. Should be able to get pretty crazy with this. So again, morning, I'm going to set the pitch angle to negative since it's in the daytime position. And I'm going to define midday, or the midday position as between 120 and 240 as far as the yaw position of the sun in the sky. I'm just going to hit save. All right, so that's the midday. And then we have the morning, And so let's go set those positions up. And here I'm just going to keep the pitch angle the same. You know, it's really based on the yaw angle that I'm more interested in the yaw angle. So I'm just going to go feed that in. So between 90, so that's the sunrise and kind of mid-morning, we're going to be about 3. And then when we go from mid-morning into the afternoon, we'll start to raise it up, the intensity. And then we'll back it back down when we get to mid-afternoon and evening. And so again, defining mid-afternoon and evening. So again, I'm just going to keep the pitch angle the same since I'm only really interested in the yaw angle. And then that's 270, that's sunset. So between mid-afternoon and evening, we're then going to bring the intensity down. And again, you can change the interpolation however you like. All right, so that will get us the sun. So the only other thing I'm going to add here is I'm just going to add the stars. And I'm doing this more because I want to be able to change the intensity and not necessarily the orbit. So I'm more interested in, but again, this could be, you know, I'm just going to put natural starlight, just put a label there so I know what we're looking at. And again, you could have a curve on there if you wanted your stars to kind of shimmy a little bit on the, yeah, as you're kind of moving. It's up to you. But yeah, but there's everything's based off again the vector curve. All right, so I'm just going to go ahead and set up 3 of these luminescence. And again, I'm going to set this up to night AM. And I'm going to make this one number 1, and this is going to be night PM. And then lastly, I'm going to set up the daytime. And as far as the luminescence for my starlight, I'm going to set this to 0.3. Actually, I'm going to make this, yeah, I'm going to make it 0.3. I'm going to keep it a little bit brighter in there, but PM, I'm going to bring this one down to 0.1 for starlight. And when we create the light sources, we'll be able to kind of set that up. But this will be controlling the actual intensity. And again, this is the intensity of the light based on, again, angle in the sky. And then during the daytime, I'm actually going to switch the light source off. So I'm going to set the intensity to 0. That way the starlight won't conflict. It shouldn't be conflicting anyway, but sometimes you may see a slight little shadow there, you know, based on where your position, especially when you're angling your sun off. So we're just going to kill that other secondary light source that's in the sky by setting that to 0. All right, so now let's go ahead and set the angles. So here again, since this is now going, we want this to be opposite, working it opposite to daytime. It's going to be working at nighttime. I'm going to set that to 67, and again, set the yaw between. So between 0 and 90, we're going to have an intensity of 3. For our starlight, that's the morning starlight. Then the evening starlight will be coming in at similar pitch angle again. .67, but we're going to be in the evening time, so we're going to be between 270 and 360, and that's going to, again, lux of 0.1, and we're going to 5 there for interpolation. And then finally, we've got our daytime, which is when we actually want to turn the light source, or turn the intensity all the way down. And again, we're going to define that as a min pitch angle of 67, negative 67, and sunrise, between sunrise at 90 degrees and sunset at 270. And again, between these angles, that's when we'll turn it off, and we've got a quick interpolation of 5 again. But again, you can customize that speed. All right, so with the absence of the curves, and we'll get to curves once we've created the sky actor. That's our data table all set up. So I'm going to go ahead and stop the video here. So in the next video, we'll go ahead and build out our Skysphere actor, and then we'll go ahead and set up the curves for our orbits. And then we'll go ahead and integrate the Skysphere actor and the orbital information and build out a map where we can actually see this in action. So if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you in part 2. Cheers. Bye.